Now, let's state theorem number 2, 3, and 4. But theorem number 4 is not examinable, so we are not going to be asked to prove theorem number 4. But theorem number 1, number 2, and number 3, we are going to be asked to prove it, to prove those theorems. The converse of theorem number 1, we have said it, that we are not going to be asked to prove the converse of theorem number 1. So the converse of theorem number 1, it's not examinable. And theorem number 4, but we are going to prove it anyway. Here we're saying that theorem number 2 states that if two triangles are equiangular, then they are similar. But before I can define theorem number 2, we need to know that we have done some examples at the beginning of part 4, and those examples were showing two polygons which are not similar, where one condition does not hold. Because we have said it that for polygons to be similar, the two conditions of similarity must hold. Therefore, we have shown that we can have polygons which one of the condition is not true. And if one of the condition is not true, then it means that the polygon is not similar. Because for the two to be similar, they need to have the two conditions to hold. Now, with triangles are very special. They are special in such a way that when one of the condition is true, then the other condition must be true. Therefore, if one condition, because we've got two conditions of similarity, if one condition for triangles is true, if corresponding angles are equal, then it means that sides are in proportion. Or if sides are in proportion between two triangles, then it means that the corresponding angles must be equal. Therefore, triangles are very special in a way that when one condition is true, the other condition must be also true. Therefore, theorem number 2, it tells us exactly about that. It says if two triangles are equiangular, by equiangular we mean that if the corresponding angles of two triangles are equal. For example, if angle A is equals to angle D, if angle B is equals to angle E, and if angle C is equals to angle G. This means that the two triangles are equiangular because the corresponding angles are equal. Therefore, the theorem states that if two triangles are equiangular, then they are similar. When we say then they are similar, it means that when the corresponding angles of two triangles are equal, then it means that the corresponding sides will be in the same ratio. That is why we are saying that if two triangles are equiangular, then they are similar. By then they are similar, meaning that sides are in proportion. Now, that's theorem number 2. Theorem number 3 states that if the corresponding sides, when the corresponding sides of two triangles are in the same ratio, then the two triangles are similar. Oh, it means that when this side over this side is equals to this side over this side is equals to this side over this side, then it means that this angle is equals to that angle. This angle is equals to that angle. This angle is equals to that angle. That's what theorem number three states. It states that if when the corresponding sides of two triangles are in proportion, then they are similar. When the corresponding sides of two triangles are in proportion, then the two triangles are similar. By then the two sides are similar, it means that this angle is equals to that angle. This angle is equals to this angle. This angle is equals to that angle. I'm not sure if I'm clear. Let us repeat this for the last time. I am saying that theorem number 2 tells that if two triangles are equiangular, and by equiangular we mean that the corresponding angles are equal. The corresponding angles are equal. Therefore, if two triangles are equiangular, then the two triangles are similar. We know that there's two conditions of similarity. The one condition is about the corresponding angles that must be equal. The other condition is that the corresponding sides must be in the same ratio, or they must be in proportion. We are saying that theorem number 2 tells us that if two triangles are equiangular, it means that if two triangles, the corresponding angles of two triangles are equal by equiangular, then it means that they are similar. By similar, it means that the corresponding sides are in the same ratio. With theorem number 3, we say that when the corresponding sides of a triangle, of two triangles, when this over that, and this over that, and this over that, when the corresponding sides of two triangles are in the same proportion, then the two triangles are similar. By then the two triangles are similar, it means that the other condition holds. Therefore, it means that this angle is equals to that angle, this angle is equals to that angle, this angle is equals to that angle. That's theorem number 3. Theorem number 4. When two sides of one triangle are in the same proportion with two sides of another triangle, I'm just going to remove here. When two sides of one triangle are in the same ratio with two sides of another triangle, with the angle included between the two sides. By included, it means that the angle is between the two sides which are in proportion. Therefore, it means that the two triangles are similar. What do I mean by that? I mean that when two sides of a triangle, when this over that is equals to this over that, with this angle included between the sides which are in proportion. Therefore, it means that this triangle is similar to this triangle. By similar to this triangle, it means that since this side and over this side is equals to this side over this side, it means that this angle is equals to that angle. This angle is equals to that angle. That's what we mean by similar. Now, let's prove theorem number 2. And we've just said it now that if two triangles are equiangular, then they are similar. Now, if I have x, y there, z there, and z there. Now, given triangle ABC and triangle DEG. Given the two triangles with, because we are just told that the two triangles are equiangular, therefore it means that we are given two triangles which are equiangular with Since they're equangular, it means that angle A is equals to, with angle A is equals to angle D, angle B equals to angle E, and angle C is equals to angle G. This is what we are given because we are told that the two triangles are equangular. Therefore, it means that we are given, since they are equangular, we are given that this is equals to that, this is equals to that, and this is equals to that. Now, we are required to prove that. We are to prove this because since they are equangular, then they are similar. Therefore, we are to prove that AB over DE is equals to AC over DG, which is equals to BC over EG. This is what we are required to prove. Now, we must construct, we want to construct HI, construct HI, construct HI such that AH is equals to DE. And we're constructing HI such that AI is equals to DG. This is our constructions. Now, for us to prove that if two triangles are equangular, then they are similar. So for us to prove that when we are given that the corresponding angles are equal, then the corresponding sides are in proportion, we just need to prove that the two triangles, this triangle and this triangle, are similar, are congruent. Once we prove that this triangle and this triangle are congruent, and by congruent we know that equal, we just think of equal. When this triangle is congruent to this triangle, it means that this triangle is equals to this triangle. It's exactly equal. They are the same. Now, once we prove that this triangle is congruent to this triangle, is equals to this triangle, obviously, by congruent, we know that we are going to prove that this side is parallel to that side. Then we're going to use theorem number 1 for us to prove that sides are in the same ratio of this triangle there. Then, since we know that this is congruent to that, then we are going to reach this part there. Proof. Now we prove it. Now, we've just said it that we want to prove that this triangle is congruent to this triangle. In triangle AHI and triangle DEG, in these two triangles, AH is equals to DE. Reason? Construction, because we've constructed there. Even if you can say const, we know it's construction. Also, AI, before I can get to AI, this angle there is equals to that angle there, because we're given that angle A is equal to angle D. Therefore, angle A is equals to angle D. Given. We are given that angle A is equal to angle D. Now, AI is equals to DG, which we have construction. Now we know we've got side, angle, side. Therefore, it means that the two triangles are congruent. Therefore, triangle AHI is congruent to triangle DEG. Reason? Side, angle, side. Since we have proved that this triangle is equals to this triangle, right? Now, we can prove that this side is parallel to that side. Therefore, A angle HI, therefore, A angle HI is equals to, since they are equal, these triangles are equal, therefore it means that this is equals to that. A angle HI, this angle is equals to that angle, is equals to D angle EG, which this angle is also equals to this angle there, which is also equals to A angle BC. Or we could have just said that A angle HI is equals to angle E, which is equals to angle B. If we wanted, we could have said this is equals to that if we wanted, or we could have said that. Now, since this is equals to that, therefore it means that this is equals to that. Since this is equals to that, we can see that A angle HI is equals to angle B. Therefore, we know that since this angle is equals to that angle, we know that HI is parallel to BC. Reason? Corresponding angles are equal. Corresponding angles are equal. Since these two are parallel, we know that this over that, AB, over AH is equals to AC over AC over AI. Here we said we must construct in such a way that this is equals to that, this is equals to that. That's what we have done. Now, since AB over AH is equals to AC over AI, why is that? It is because of a segment is parallel to one side of a triangle. That's theorem number one. When a segment is parallel to one, or if a line is parallel to one side of a triangle, therefore it divides the other two sides in the same proportion. It divides the other two sides in the same proportion. So segment parallel to one side of triangle. Segment parallel to one side of a triangle. That is why we have the two sides that are going to be in the same proportion. Now, we know that AH is DE. Therefore, AB over DE is equals to AC. We know our AI, which is DG over DG, which AB over DE there is equals to AC over DG, of which we have proved this part of our theorem, but we can use a similar thing to prove approach to prove that AC over DG is equals to BC over EG. I leave this to be an exercise for you guys to prove the last part. I've just proved that this is equals to that. So it is for you now to prove that this part is equals to that part. I leave this part as an exercise. This is how we prove theorem number 1. As long as we can prove that the two triangles are congruent, then once they are congruent, then it means that we can prove that this side is parallel to that side. Once we have proved that this side is parallel to that side, then we can use theorem number 1, because when this side is parallel to the third side, then it divides the other two sides in the same proportion. Then we can include here our reason why we said that. We know it's construction, because we have constructed that AH must be equals to, in such a way that AH is equals to DE. That is why here I need to give my reason that from here to here, it's construction. I just want to add on equiangular triangles. We have just said it that two triangles are equiangular when the corresponding angles are equal. Not only when all the corresponding angles are equal, even when two interior angles of one triangle are equals to two interior angles of another triangle, then the two triangles are equiangular. No need for all of them. As long as two corresponding angles are equal, then the two triangles are equiangular. Why is that? It is because we can find angle A, and thus we can see that angle B is equal to angle E, angle C is equal to angle G. For us to find angle A, we know angle A is going to be equals to this plus this plus this equals to 180, sum of angles on a triangle. Then we're going to take this angle to the other side where we have 180 degrees minus y plus z minus y plus z. Why is that? It's sum of angles on a triangle. I got this by adding this plus this equals 280. Then taking these two to the other side, that is why I have that. Even angle D, let's see, angle D is equals to also 180 minus y plus z. Therefore, it means that this angle is equals to this angle is equals to that angle. You can see angle A is equals to angle D here. Therefore, when two interior angles of one triangle equals to two interior angles of another triangle, then the two triangles are similar. No need for us to even look at the last angle. When only two of them, two corresponding angles are equal, then the two are equangular. Then the two are equangular. Now, let's prove theorem number 3, which states that when the corresponding sides of two triangles are in proportion, then they are similar. Now, for us to prove theorem number 3, we are given triangle ABC and triangle DEG. With, because we are told that when the corresponding sides of two triangles are in proportion, therefore it means that we are also given that AB over DE is equals to AC over DG, which is equals to BC over EG. This is what we are given because we are told that the theorem states that when the corresponding sides of two triangles are in proportion, then they are similar. So we are required to prove that angle A is equals to angle D, angle B is equals to angle E, and angle C is equals to angle G. Because we've just said it, that theorem number 3 states that when the corresponding sides are in proportion, then the two are similar. So it means that then we've got an equangular triangles. So we need to prove that the angles, corresponding angles, are equal. Now we need to construction. We draw HI such that AH is equals to DE and AI is equals to DG. Now, for us to prove this theorem, we're still going to prove that this is congruent to this triangle. This triangle is congruent to this triangle. Since we know that this triangle is going to be similar to this triangle, then it will mean that this triangle will be similar to that triangle, since this triangle is congruent to this triangle. So congruence is important in the proofs of these theorems, because once we prove that this is congruent to this, it means that this triangle is equals to that triangle. Then we know that when this triangle is similar to this triangle, it will mean that this triangle is going to be similar to that triangle there. Now let's prove. We are given AB is equals to, AB over DE is equals to AC over DG. That's what we are given. Risen? Given. Now, we know that AB over our DE, we know it's AH, which is equals to, we know our DG is AI, risen, construction. We know construction. Therefore, since AB over HI is equals to AC over AI, we know that since this, it means that HI is parallel to BC. That's what we know, since the sides are in proportion. Reason why we're saying that this is parallel to that, it is because segment divides sides proportionally. That's why this is parallel to that. Now, since this is parallel to that, we know that angle B is equals to A angle H I, A angle H I, this angle is equals to that angle there. Risen, we know that we've got corresponding angles. Why? Because HI is parallel to BC. Also, angle C is equals to A angle IH. We still have the same reason, corresponding angles. HI parallel to BC. Now, since this angle is equals to that angle, this angle is equals to that angle, at the end of proof of theorem number 2, we've said that when two angles of one triangle are equals to, when the interior angle, two interior angles of one triangle equals to two interior angles of another triangle, then this triangle is similar to this triangle, since the two angles are equal there, as we have seen at the end of the proof of theorem number 2. Therefore, triangle AHI is similar to triangle APC. Since this triangle is similar to this triangle, then we know that, therefore, the two triangles are equiangular triangles. I need to put triangle AHI is similar to triangle APC. Reason why we're saying these two are similar? Because we've said it that when this is equals to that and this is equals to that, when two interior angles are equals to two interior angles of another triangle, then we've got equiangular triangles. Therefore, reason equiangular triangles. Now, since these two triangles are equiangular, we know that we can say HI over BC, because this is similar to that. Therefore, it means that this over that over BC is equals to, since I started with the small triangle over the big triangle, I'm going to start with the small triangle AH over AB. Now, this, we know our AH is DE. DE over AB, obviously, because we've just put DE where we see AH. This, here we know construction. Now, since we know that DE, since we know that AB over DE is equals to BC over EG. Even here, we can still, because I've got BC there, you can see I've got BC there. But my BC is in the denominator, my HI it's on the numerator. So DE, which is, if it's AB over DE, it has to be equals to AC over DG. But if it is DE over AB, it means that it's going to be equals to DG over AC. That's what it means. Therefore, it means that this here, DE over AB, is the same as EG over BC, is the same as EG over BC. Here we know why DE over AB is equals to DG over BC. It is because we're given that. Given. The whole point here is to prove that this triangle is congruent to this triangle. But we have used similar triangles. We have used that this triangle is similar to this triangle. No need to cram these proofs. Since we want to prove that this angle is equals to that angle, this angle is equals to that, this is equals to that, we need to prove that this triangle is congruent to this triangle. And by proving that this triangle is congruent to this triangle, we have used the similar triangles. We have used this triangle to be similar to this triangle. Therefore, once we get that this side is equals to that side, then we have proved that the two triangles are congruent, because we have constructed in such a way that this side is equals to this side. We have constructed HI in such a way that this side is equals to that side there. Therefore, we are proving congruency in such a way that we need to prove that, because we know that this side is equals to that side, this side is equals to that side. If we can get that this side is equals to this side, then we have proved that the two triangles are congruent. Once we have proved that the two triangles are congruent, since these triangles are similar, since this is similar to that, or since this is equiangular to that, it will mean that this is equiangular to that. That's what it simply means. Therefore, what I can see is that I can drop this HI over BC is equals to EG over BC. Oh, so this means that, therefore, HI is equals to EG. So it means that HI is equals to EG. Therefore, triangle AHI is congruent to triangle DEG, is congruent to triangle DEG. Why are they congruent? Because side, side, side. This side is equals to that side. This side is equals to this side. We've just proved now that this side is equals to that side. Therefore, reason side, side, side. Two triangles are congruent. Now, it means that, therefore, I'm just going to finish with this proof here. Therefore, triangle ABC is similar to triangle DEG. Why? Because they're equiangular. Triangle. Here we say that triangle ABC is similar to triangle DEG. Why? It is because triangle AHI is similar to triangle ABC. And since triangle AHI is similar to triangle ABC and triangle AHI is congruent to triangle DEG, it means that triangle ABC is similar to triangle DEG.